What makes an absolute value equation a little bit different is that it's going to lead us to setting up two different equations that we need to solve. And this is just based on essentially the definition of absolute value. One way to think of absolute value is that it's a distance from 0 on the number line. And so this is saying that the expression 2x minus 1 is 5 units away from 0. Well, there's two different places that are 5 units away from 0 on the number line. I could either go to the right from 0 and 5 units and I'd end up at 5. Or I could go to the left 5 units and I'd end up at negative 5. So this equation would be satisfied if that expression inside that 2x minus 1 was equal to 5 or if it was equal to negative 5. So those are going to be my two equations that I set up. My first one, I can say that that inside expression equals 5, or my second one, that inside expression equals negative 5. Okay, you'll notice at this point I don't have the absolute value bars anymore, okay, because I've split it into two equations. I've dealt with that absolute value. That's what led me to the two equations. And also we don't change anything about that expression inside. It's still 2x minus 1. Okay, so now we just need to solve each of these two equations separately, and that'll give us our two solutions. So from the first one here, we're going to get x equals 3. And from our second one, we're going to get x equals negative 2. So our two solutions to this absolute value equation are negative 2 and 3. So you'll notice they're not opposites of each other, so we can't just get away with solving that first one and then thinking that our second solution is the opposite. That's not the case here, and so you could again plug each of these back into the original equation to check, and they would both work.